Hello, I would like to take a look at evaluating some limits here. And these are three examples of limits that require a little bit tricky type of factoring to get all set and good. So in this first one, we have the limit as x approaches 5 of 5 minus x divided by x squared minus 25. And we can see that when we try direct substitution, which we should always try first, we get a 0 in the denominator because 5 squared is 25 and 25 minus 25 is 0. So we have a problem. But we can see that it appears that the denominator factors with a difference of squares, so we want to try that first. And we end up with x minus 5, x plus 5. Okay, almost good, except if I try to cancel out these terms, they're not exactly the same, okay? 5 minus x and x minus 5 are not the same. They're a little bit different. In fact, they're off by a negative 1. So what we do is, out of the top, we can factor out a negative 1. That would change the sign of both of those terms. So I now have negative 1 times negative 5 plus x, and the same thing on the bottom. And now maybe you can see, instead of negative 5 plus x, well, because addition is commutative, I can rewrite that as x minus 5. I can change the order around. So notice what I did. Instead of negative 5 plus x, I switched the order and it's x minus 5. Hey, and what do you know then? Those are now the same, so I can cancel it out. And it now equals the limit as x approaches 5 of negative 1 over x plus 5. So it's a small difference in that I now have a negative 1 up top instead of just a 1 when I cancel out. And now if I try direct substitution, I have negative 1 over 5 plus 5. Nothing is the issue with that. Negative 1 over 10, and I have my limit. Okay, an easy little factoring technique there to factor out the negative 1 to make it match the bottom. But remember that negative 1, it changes the answer. Okay, well, how about this one now? Now I have e to the 2x minus 1 divided by e to the x minus 1. When I plug in 0, try direct substitution, well, in the bottom I have e to the 0 minus 1, which is 1 minus 1, which is 0. A problem, cannot divide by 0. So we gotta try something. And we're going to mess with this e to the 2x. E to the 2x, when you see that, recognize that we can rewrite this with a power to a power. I can rewrite it, let me just say x times 2 for right now. Okay, I flip the order of multiplication. Multiplication is also commutative. I can change the order. Well, e to the x times 2 is same as e to the x power 2. When you have a power to a power, what's the rule? You multiply. Okay, so you have x times 2, which takes us back here, which takes us back here. So what I'm trying to say is I can take this limit and I can rewrite e to the 2x as e to the x squared minus 1. And maybe now you can see where we're going with this one. Because what do I have? I have a squared minus b squared. E to the x is a perfect square. 1 is a perfect square. So I can factor the top as a difference of squares. Yes, even with our exponential, we can find a neat way to do some factoring with it. So e to the x minus 1, e to the x plus 1. And now my e to the x minus 1 on the denominator can be canceled. Hey, alright. So I can now write my limit as x approaches 0 of just e to the x plus 1. I can now plug in, direct substitute. E to the 0th is 1. 1 plus 1 is 2. And I found my limit. I found a way to force it into the difference of squares for me. Okay, how about some trigonometry? So, when I find this limit as x approaches pi over 4, I end up with sine pi over 4 minus cosine pi over 4, which we should know our unit circle well in these basic values. This is square root of 2 over 2, and the same for the cosine pi over 4, which means I end up with 0 in my denominator. Bad. So I gotta mess with this. I gotta try this. And this is probably the weirdest, interesting factoring method I'm gonna show in this video. Tangent x. What's another way to write that? Well, sine x over cosine x. And then the bottom, we'll just let it stay the same for now. Sine x minus cosine x. Now this is a really hard one to see, but I want to somehow create something on the top where I can cancel it out with the thing on the bottom. Now what we're going to do is factor out a 1 over cosine x from both of those. Let me rewrite the limit one more time to see how we can do that and what that's going to look like. The limit as x approaches pi over 4. What's another way to write 1? Well, if I really want to, I can say it's cosine x divided by cosine x. Minus, I can write this as sine x times 1 over cosine x. When I write it this way, I think you can agree with me that both of these top terms are equivalent to the top terms in our first limit. It's just when I write it like this, and now when I factor out a 1 over cosine x from the top, we can see what's left. So if I factor a 1 over cosine x, that takes that out of the equation, and that takes that out of the equation, leaving me just cosine x minus sine x, all divided by sine x minus cosine x. Pretty clever. And this now harkens back to our first problem that we tried here. Because now, the top and the bottom are not the same exactly. But if I factor out a negative 1, so I just stuck it on top of my 1 over cosine x, I now have negative cosine x plus sine x. And on the bottom, sine x minus cosine x. And you can see, if I erase this and I just flip the order, I now have the same thing as the bottom. Hey, all right. Cross them out, cancel them out, and I get the limit as x approaches pi over 4 of negative 1 over cosine x. And now when I plug in pi over 4, I no longer have 0 in the denominator. I only have square root of 2 over 2. And if it's negative 1 divided by that, it's the same as multiplying by the reciprocal. So I have negative 2 square roots of 2. Okay, I hope this video has showed you some interesting ways and applications of factoring techniques that you can apply to work out some of those tricky limits.